bridging the gap from classroom theory to industrial reality. In a recent interview, I was asked about my hands-on experience with PLC programming, SCADA systems, and industrial instrumentation tools. The interviewer made a striking comment: "These aren't typically taught in school." That statement hit me and it stayed with me. Because it's true. Most engineering programs are saturated with theory, control systems equations, Laplace transforms, signal modeling. But when you walk into a real plant, factory, or processing facility, the reality is completely different. You graduate with a solid foundation in engineering, but then you step into an industry that speaks a different language. Ladder logic, I/O modules, PID tuning, OPC-UA, Modbus, Fieldbus protocols. So the big question is, where exactly do we learn the tools that actually run the industrial world? For me, it was never in a lecture hall. It was a journey, self-paced learning, hands-on experience, certifications, and long nights configuring SCADA tags, debugging PLC programs, and working through faults with zero room for guesswork. Now it's time to pay it forward. I'm launching a practical series that will walk you through the foundational pillars of instrumentation, automation, and control engineering, but from an industry-first perspective. If you're a student, a recent graduate, or even an engineer transitioning into controls and automation, this series is for you. Let's begin with some context. By definition, instrumentation is about measuring physical parameters: temperature, pressure, flow, level, vibration, you name it. Automation is the use of control systems like PLCs, SCADA, or DCS to run operations automatically with minimal human input. While control engineering is designing and tuning the control loops like PID loops that keep systems stable and optimized. Now that we've set the stage, here's what's next. In the upcoming episodes, we'll get hands-on starting with PLC programming using OpenPLC, a free and open source platform you can install on your PC. I'll walk you through key concepts, scan cycles, I/O mapping, tag management. You'll see how digital inputs become meaningful actions in automation systems. In my next post, I'll guide you step by step on how to download, install, and configure OpenPLC from scratch. By the end of it, you'll be able to turn theoretical knowledge into practical skills you can showcase in any job or project environment. If you've ever felt that what you learned in school doesn't match what's expected on site, this series is for you. So don't miss out. Like, share, and follow, because we're just getting started. And remember, the real world runs on control systems. Let's make sure you know how to build them.